This is a rough copy of my physics IPT ballistic simulation, featuring kinematics and dynamics, but most notably, I've sort of simulated air resistance. So here we are. I can adjust the angle at which I launch my bullet. Let's give it 15 degrees. There we are. So the red line is the component of velocity, and if we look directly at the bullet, this is the drag force. So that hits the ground, and it hits about 3.4 kilometers. We can adjust, let's say 45. So this simulation is based off of a standard drag equation for bullets. And so it takes the cross-sectional area or the front area of the bullet, multiplies it by the dynamic air pressure, and so this varies with the velocity compared to the air density. And air density is actually simulated here as well. So air density will be thinner at different heights, and so will the speed of sound, which also affects the drag on a bullet. So over here I have a graph. This is the G7 graph, and this is basically how the coefficient of drag varies at different Mach speeds. And so it's working off of that. The speed of sound varies. Drag varies based on how fast it is, and in different ways. And yeah. You can input different bullet properties. So I have different calibers with different masses, different muzzle velocities here. And so I can input the data. So on our last hit, we hit about 4.3 kilometers. This time with a heavier bullet. Nope, lighter bullet, but interesting. Well, let's see, actually. Where will it hit? Where will it hit? It'll hit at about 4 kilometers. Interesting. So, you can see that it's skewed. It's not quadratic, and this is because there are more forces acting on it horizontally, which would be 0 in our normal 12th grade physics equations. And this is actually very difficult to plot as a full equation, just because the air pressure will vary depending on altitude, and then so will speed of sound because the air pressure varies. And so being able to simulate forces at every moment, so instantaneously, is very useful for this kind of simulation. G7 isn't actually technically completely accurate for the bullets that I'm testing, but there isn't that much data for these specific cartridges, so this is the closest I could get. Yeah, that's that. Just for the fun of it, I'm going to shoot it at about 85 degrees. So for scale, actually, these are meters. We're looking at a pretty large scale right now. It's about 3 kilometers in the sky right now. This is probably not how you would want to be shooting at someone. However, will no doubt hit. There we are. About 700 meters.